Miniaturized satellites. CubeSats are an example of miniaturized satellites or small satellites. Small satellites have low mass, usually under 500 kilograms or 1,100 pounds. Depending on mass and size, miniaturized satellites also have subcategories. Typically, the wet mass for such satellites, that is the mass including fuel, is between 100 and 500 kilograms. Why use miniature satellites? One reason for miniaturizing satellites is to reduce the cost. Heavier satellites require larger rockets with greater thrust, which also costs more. In contrast, smaller and lighter satellites require smaller and cheaper launch vehicles, and can sometimes be launched in multiples, in a constellation. Smaller satellites can also piggyback on larger launch vehicles or use excess capacity from larger launch vehicles. Their designs are cheaper and allow mass production, and they can be used in communications constellations, for example, with more than one satellite acting together. Miniaturized satellites also permit new use cases, such as gathering data from multiple points, university-related research, etc. While miniaturized satellites have traditionally been launched as secondary payloads on larger launch vehicles, there are a number of companies currently developing launch vehicles specifically targeted at this segment. These include Virgin Galactic's Launcher One, Firefly Space Systems Alpha, etc. Miniaturized satellites can be classed as microsatellites, nanosatellites, picosatellites, and femtosatellites. The term microsatellite is usually applied to satellites with a wet mass between 10 and 100 kilograms, or 22 and 220 pounds. Nanosatellites have a wet mass between 1 and 10 kilograms, 2.2 and 22 pounds. Picosatellite is a term usually applied to satellites with a wet mass between 0.1 and 1 kilogram, or 0.22 and 2.20 pounds, although it is sometimes used to refer to any satellite that is under 1 kilogram in launch mass. CubeSat, with approximately 1 kilogram, or 2.2 pound mass, is an example of a large picosatellite, or a small nanosat. Femtosatellite is usually applied as the name of an artificial satellite with a wet mass between 10 and 100 grams, or 0.35 and 3.53 ounces. In March 2014, the nanosatellite KickSat was launched aboard a Falcon 9 rocket with the intention of releasing 104 femtosatellite-sized chipsats, or sprites. CubeSat. A CubeSat is a type of miniaturized satellite for space research that usually has a volume of exactly 1 liter, or 10 centimeter cube, has a mass of no more than 1.33 kilograms. CubeSats typically use commercial off-the-shelf components for its electronics. While the bulk of development and launches come from academia, several companies build CubeSats, such as Boeing, and several small companies. CubeSat projects have even been the subject of Kickstarter campaigns. CubeSats are typically launched and deployed from a mechanism called a polypicosatellite orbital. Most CubeSats carry 1 or 2 scientific instruments as their primary mission payload. Aurdosat. Aurdosat is an open-source Arduino-based nanosatellite based on the CubeSat standard. It contains a set of Arduino boards and sensors. Aurdosat's goal is to democratize access to space. Aurdosat is the first open-source satellite which will provide such open access to the general public to space. The Aurdosat project currently consists in 2 identical satellites, Aurdosat 1 and Aurdosat X. Aurdosat is Arduino-based and is equipped with 16 processor nodes, ATmega 328P, and one supervisor node, ATmega 2561. The processor nodes are dedicated to the computing of the experiments, each on one node. The supervisor uploads the code to the processor nodes. The Arduino processors may sample data from sensors, such as accelerometers, infrared temperature sensors, optical spectrometers, etc. The experiments for Aurdosat are developed in C, C++ for AVR Arduino using the Aurdosat SDK. Aurdosat is equipped with a half-duplex UHF transceiver, operating in the 435 to 438 MHz amateur radio satellite band.